In this lesson, we want to be able to say that I can identify and use special pairs of angles. First thing we want to do is be able to identify what the special pairs of angles are. We have, first up, the adjacent angles. Adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So for example, here's something that's adjacent. If we have this angle right here, let's call this angle 1. And then we have another angle that is joined at the vertex. The vertex is whenever the two rays are connected to form the angle. And we have another angle here, which we're going to call angle 2, that share this side right there. Then this is adjacent. So angle 1 and angle 2 are adjacent angles because they share the vertex and one of the sides. An example of a non-adjacent angle. We could have, let's say we have this angle right here. That could be angle, let's say angle 1. If we have another angle, let's have it connected with the vertex, but let's not have any sides be shared. These are not adjacent because they do not share a side. Yes, they share the same vertex, but they do not share a side, so that is a non-adjacent angle. Remember, adjacent angles, they have to share the vertex and also one of the sides in order for it to be adjacent. If they don't share that, then it's not adjacent. Also notice what I had said earlier. There is no point that they have interior of both of them. So if we have this point, let's call this point A. Point A is only an angle 2. It's not an angle 1. There's no such point that would be in both of them, interior to both of them. Linear pair. Let's talk about what it means to have a linear pair. This is another special type of angle. A linear pair is whenever we have a pair of adjacent angles, so they have to be adjacent, so what we just talked about, with non-common sides that are opposite rays. Okay, so let's look at that. Non-common sides which are opposite rays. Opposite rays means that we have a straight line. So we have a straight line for opposite rays. Let's call this point A. Let's put some points on here so that these will be B and C. And we know that there is going to be another angle in here. So let's just put another ray from point A going this way. So we can have this angle which is going to be CA, let's call this point D. So we have angle CAD and angle DAB. These are two adjacent angles. They are connected with the vertex and one of the sides. However, the opposite rays are not shared. Okay, the opposite rays are not shared. An example of, or a non-example of a linear pair could be like this. If we have this ray over here, we can have this ray go this way, and we can have this ray go this way. Notice there is no straight line in there. We don't have opposite rays. Opposite rays always form the straight lines. Let's call this point A. Let's call this point B. Let's call this point C. And let's call the middle point D. We have angle ADC and BDC. These two angles right here, they are adjacent, but they are not linear pairs. Linear pairs must be adjacent angles and also have opposite rays. So that is what a linear pair is. Vertical angles. Two lines that cross form vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. So if we have two lines that cross, let's have that line. Let's have this line. Two lines that cross, we know they will be vertical angles anytime two lines cross. Vertical angles are the angles that are not adjacent. So this angle right here and this angle on this side are vertical angles. So let's call this angle 1. Let's call this angle 2, angle 3, angle 4. We have 4 angles here. So we are going to say angle 1, and let me put this sign for angle. Angle 3 are vertical angles. And we also would know that angle 2 and angle 4 are vertical angles. So those would be vertical angles in this situation. Whenever 2 lines cross, we always have 2 pairs of vertical angles. A non-example. If we have, let's say, this line that's over here, let's have a line go this way, or a ray go this way. Let's have another ray go this way. These are not vertical angles. None of these angles can be vertical because they're not 2 straight lines crossing. Remember, vertical angles are non-adjacent. They share one vertex, but they're not adjacent, meaning they do not share a side. And they are formed whenever we have 2 straight lines. Let's look at this example right here. Use a figure to answer the following. Name 2 angles that are adjacent. There's a lot of angles in here. And there's a lot of angles that are adjacent to each other too. But I'm going to let's pick on this angle right here. Let's go with this angle centered at vertex B. So we can have angle CB, and let's go to A, CBA, because that is a point on this other ray. And we also know that angle, they have to share a side, so CB will be the side in common, and we can have it go all the way to D. So these 2 are adjacent angles. We could list off some more. We could have the angle, let's say angle 1 and angle 2. These 2 angles are adjacent. This angle right here with this angle right here. Those 2 are adjacent. They share a side and they also share the vertex. We have part B. Name 2 angles that are linear pairs. Remember, linear pairs, they have to be adjacent and they have to form a straight line. They have to be opposite rays. So if we want to have the linear pair with this, we are going to have, we can say angle 1 and angle 2 are linear pairs. They are adjacent. They are adjacent to each other. They share ray AY, and ray AZ and AF are opposite rays. This ray and this ray are opposite rays. They are a linear pair. We could also name off another one. Let's go with a different linear pair. Let's say we have the linear pair right here. Let's look at this angle. EF to H. EFH with HFG. Those are linear pairs. Yes, there's an extra ray inside of EFH, but we don't have to count that. So we can say angle EFH and angle HFG. These are linear pairs. They form a straight line. They are opposite rays for ray FE and FG. Name 2 angles that are vertical. Okay, any lines that cross form vertical angles. So we are going to just find 2 lines that cross. So one line that crosses is right here. So we have line FB. This is a line that crosses. And we also could look at this line right here. We could look at line AF. Okay, 2 lines cross. They form vertical angles. So let's find the angles that are non-adjacent. Isn't angle 11 and angle 8 non-adjacent? They share vertex, but they're non-adjacent. So we can say, well, angle 8 and angle 11, they're vertical. We could also look at angle 1 and 3. There are lots and lots of examples. 2 lines cross, vertical angles. So angle 1 and angle 3 would be vertical in this situation. There's lots in that example. Congruence of vertical angles. Vertical angles are congruent. Congruence, remember what congruence means. Congruence means that they are equal in measure. So we can say that angle 1 and angle 3 are congruent. So angle 1, remember this is our signal we use for congruence, is congruent to angle 3. And remember, congruence means that the measure of angle 1 equals to the measure of angle 3. That's what it means to be congruent. They have the same measure, the same degree. Complementary angles, some more special angles. Complementary, we have 2 angles that their sum is equal to 90 degrees. So if we have, let's say, let's go with this ray right here and this ray right here. Let's say we know that this is 90 degrees. And let's make another ray that goes over here. Let's put some points on here. We have A, B, and C. And let's put this as point D. We can say that angle A, B, C and angle C, B, D are complementary. This is because the measure of angle ABC plus the measure of angle CBD equals to 90 degrees. The sum of them add up to 90 degrees. That's whenever you know it's complementary. Notice whenever I said complementary, it does not say anything about them having to be adjacent. These do not have to be adjacent angles. So if we have, let's say, an angle that looks like this, let's call this angle 1. And let's say we have another angle that is not adjacent to it, meaning they do not share a side and a vertex. Angle 2. We can say, okay, well, angle 1 and angle 2 are complementary because the measure of angle 1 plus measure of angle 2 equals to 90 degrees. Okay, so supplementary. Let's go to supplementary angles. Supplementary angles are similar to complementary angles. However, instead of adding to equal 90 degrees, they add to equal 180 degrees. So they add to equal to a straight line. They add to equal a straight line. So here's an example of this. If we have a line or a pair of opposite rays, and we have a ray that goes up with it, this is similar to linear pair. We're going to talk about that in a moment because supplementary and linear pairs are very, very similar. Let's call this angle 1 and angle 2. If we know that angle 1, the measure of angle 1 and the measure of angle 2, if we know that their sum equals to 180 degrees, then we know it's supplementary. It's also true for supplementary angles that they do not have to be adjacent. So we could have an example that looks like this. We could have this ray over here. We could have another ray that just happens to be a little bit farther away. That could be over here. If this is angle 3 and angle 4, then if we know that the measure of angle 3 plus the measure of angle 4 is 180 degrees, then we know that they are supplementary. Complementary, add to 90. Supplementary, add to 180. Here's a quick question. Are supplementary angles also considered to be linear pairs? Sometimes. It depends. If the supplementary angles are adjacent to each other, meaning they share a vertex and a side, then they are linear pairs. Linear pairs are always adjacent. So linear pairs are always supplementary angles, but supplementary angles are not always linear pairs. Okay, make sure you know which direction we're going. Supplementary angles are not always linear pairs, but linear pairs are always supplementary. Here's an example. Let's actually do a little bit of math, a little bit of algebra in here. Find the measure of 2 complementary angles if the measure of one angle is 6 less than 5 times the measure of the other. Let's call one of the angles x. I'm going to say angle x plus, we know that the other angle, so we're going to look at the other angle. The other angle is 6 less, so we need to subtract 6 from 5 times the first angle. Complementary means that they add to equal 90 degrees, so this should add to equal 90, right? X is the original angle. The other angle that we look at is 6 less than 5 times that amount. So make sure you understand how those words work together to be able to form an expression. From here, let's go ahead and simplify this. So this would be 6x, because 1x plus 5x is 6 of them, minus by 6 equals to 90. We are going to add 6 to both sides. So we end up with 6x equals to 96. And we are going to divide by 6. Divide by 6. So we are going to end up with, let's go ahead and do 96 divided by 6. 6 into 9 is 1, so that's 6. Subtract, we have 3 remaining. Bring down 6. 6 into 36, 6 times. So x is 16 degrees. That's a measure of one angle. Now let's find the measure of the other angle. The other angle is 5 times the first angle, so 5 times 16 minus by 6. Well, 5 times 16 is 80. 80 minus by 6 gives us 74. Here's a quick question. Is 16 degrees plus 74 degrees equal to 90 degrees? Because if it is, then we are good. If it's not, then we messed up somewhere. So always remember, you need to check your work to make sure that it actually does equal that value. Last thing, very last question we have. Find the measure of two supplementary angles if the measure of one angle is 6 more than half the measure of the other angle. So this is very, very similar to the last one. It's just set up a little bit differently. Last one we did complementary. This one we're going to do supplementary. Supplementary adds to equal 180 degrees, while complementary adds to equal 90 degrees. So let's do the same thing. Let's call the first angle x. We can call it y. We could call it z. It does not matter which variable you decide to choose. We're going to add this to the other angle. We know that this other angle is 6 more, so that's add 6, then half the measure of the original. So half x plus 6 is the other angle. Okay, well, let's use our algebra skills. So we have x plus half x plus 6 equals to 180. Whenever we solve an equation, we like to have it simplified. We don't generally like to have fractions or decimals, so let's get rid of that fraction by multiplying by the denominator. Let's multiply everything by 2. So 2 times x is 2x. 2 times half is going to be 1, so this will be plus 1x. 2 times 6 is 12. And 2 times 180 is going to be 360. Combine the x's, so this is 3x plus 12 equals to 360. Subtract by 12. Subtract by 12. So we end up with, let's go up here, 3x equals to 348. Let's divide by 3. Divide by 3, divide by 3. So we have x, let's go 348, divide by 3. 3 into 3, 1 time. That's 0, bring down the 4. 3 into 4, 1 time. That's 3, 1 remaining, bring down the 8. 3 into 18, that is going to be 6 times. So our answer is x equals to 116 degrees. That is the first angle. Let's find the second angle. The second angle is half of this, and then 6 added on top of that. So let's go. Half of 116 plus 6. So 116, let's go 116 divided by 2. So this would be, goes into 11. That would be 5 times. That's 10. Subtract 1 remaining. Bring down the 6. 2 into 16, that's going to be 8. So we end up with 58 plus 6, which ends up to be 64 degrees. And let's just quickly check. Is 116 degrees plus 64 degrees equals to 180 degrees? If it is, then we're good. If it's not, then we need to go back and check our work.